Okay, today I want to talk about section 1.9, the matrix of a linear transformation. This is like outline. The first one, I want to talk about a standard matrix for linear transformation. Second one, common geometric linear transformations. What is it like onto transformations? What is one-to-one transformations? The first example, the columns of I2, like I2 like identity matrix, 2 by 2 identity matrix here, the 1, 0, 0, 1. The E1 is first column, 1, 0, E2 is second column, 0, 1. Suppose T is a linear transformation from R2 into R3 such that TE1 equals 5, negative 7, 2, TE2, negative 3, 8, 0. Find a formula for the image of an arbitrary x in R2. So how can you find these kind of things? So we can find the formula is like this. Was it like x? So we have right here, the vector x is like x1, like x2. So we have it. So we can change this one to the x1 times 1, 0 plus x2 times 0, 1. This is possible. We can split linear combination by using E1 and E2. So this is x1, E1 plus x2, E2. Like this. So this is like linear the transformation. So we can calculate Tx. Tx is same to T of x1 times vector E1 plus x2 times vector E2. Select linear transformation. You can change it to the constant coefficient x1 times the T E1 plus x2 times T E2. So like this. So x1 times what's T1? T1 is given the 5, negative 7, 2. The 5, the negative 7, 2. Plus x2 times T2. The T2 is here. The negative 3, 8, 0. The negative 3, 8, 0. So what's that? So this is the same to 5, negative 7, 2. This is negative 3, 8, 0. We have this kind of forms times vector x1, x2. So we have this one. What is the matrix? The first column is exactly TE1. So we have TE1. The second vector, second column is TE2 here, TE2. Times vector x. This is like one good formula for finding the area. So this is matrix A. This is matrix A. A times x. What's A? The first column is TE1. The second column is TE2. That's it. This is the whole idea for finding formula. The next, the A standard matrix for linear transformation. The every linear transformation from R to N, Rm can be viewed as a matrix transformed X is going to A times X. A is like the M by N matrices, right? This was like A. So A is the same to M by N matrix. The important property of T are related to the familiar property of A. The key to finding A. How can you find the finding A? So T is completely determined by what is it does the columns of the n by n identity matrix IN, right? Here, the previous example. This is like idea, exactly this one. This is key. So let T from Rn to Rm be a linear transformation. Then there exists a unique matrix A such that Tx equals Ax for all x in Rn. The A is m by n matrix whose jth column is the vector Tej. The Ej is the jth column of the identity matrix Rn. What does it mean, Ej? Here. So Ej, the all part is 0. This portion is 1. Other part is also 0. Was like 1. This is jth term. It's like a jth one. So this is Ej. Only one part is unit 1. The other entries always 0. So was like A. From the previous example, we have TE1, TE2 till TEN. This is exactly matrix A. This is the whole idea for finding the formula for Tx. The matrix A is the standard matrix for the linear transformation. So we call the like this one. Was like a standard matrix for the linear transformation. Find the standard matrix T given T equals R3 to R2, TE1, TE2, TE3 is given. How can you find standard matrix? So not difficult. The standard matrix A is exactly same to the TE1. Here TE2, TE3. So what's it like a TE1? The first column 1, 4. T2, second column, -2, 9. The third column here, 3 minus A, 3 minus A. That's it. This is a standard matrix. This is a standard matrix. Of linear transformation T. This is whole idea. The next one. So that T is a linear transformation for finding a standard matrix that implements the mapping Tx1, x2 equals x1 plus 4x2, 0, x1 minus 3x2, x1. So I can do that. So we can use this method here. You can write this linear transformation a little bit different here. This is T of, you can change the matrix form. This is the x1, x2. Exactly same to, we have first entry, x1 plus 4x2. The second entry, 0. The third entry, x1 minus 3x2. x1 minus 3x2. The last entry is x1. The next two, you have to split x1 part and x2 part. We have x1 part here, x1, 0, x1, x1, is right here. x1, 0, x1, x1. Plus, the second one is 4x2, 3x, negative 3x2 here, 4x2. The second one is always 0. Next one is negative 3x2. Last one, we don't have x2 term, 0. So you have to split x1. So take out x1. So we have 1, 0, 1, 1. Plus x2. Take out x2. So 4, 0, negative 3, 0. So what's that? You can change this one to the A times X form. Here we have first column is this one. 1, 0, 1, 1. The second one is 4, 0, negative 3, 0. 4, 0, negative 3, 0. Times vector x, x1, x2. We change it like A times X form. So this is what? Standard matrix. Standard matrix of linear transformation T. So what does it mean? The matrix transformation is always linear transformation, right? So we know the matrix transformation is a linear transformation. We can use this result. So this is what? Exactly linear transformation. This one is the same to T. So we have this conclusion. T is a linear transformation. So that's it. This is a proof. How can prove? You can change this one to the standard matrix form. That's it. So this is exactly linear transformation. The next one, the T is R2 to R3 be the linear transformation with Tx1, x2 is like this. So how can do that? The same. So you can change it. This one is T. Here, we can change it. This one to the T x1, x2. Same to can change matrix form. The Tx1 negative x2. Here, the negative 3x1 plus x2. The 2x1 negative 3x2. You can change it like this and change it to the matrix A and the vector x form. How can you do that? Here, the coefficient of x1 is 2, negative 3, 2. We have 2, negative 3, 2. This is the first column. The coefficient of x2, the negative 1, 1, negative 3. The negative 1, the 1, negative 3 times vector x. That's it. This is exactly linear transformation. So this matrix is standard matrix. Standard matrix. So what's it like question? The Tx equals 0, minus 1, 4. You can solve. This is same to what? 0, minus 1, minus 4. You have to solve this equation. Ax equals b, right? This is exactly, you solve Ax equals b. You solve this one. How can you solve? You can change it to the augmented matrix. You can change the augmented matrix. What's like augmented matrix? So we have this one. So first column is matrix A. You can derive matrix A to the negative 3, 2. Second one, minus 1, 1, negative 3. The B is 0, minus 1, minus 4. So we have this kind of things. The next two, you can change it to the echelon form. So how can change? So like this. So you have to, this is like the first law, this is the second law, this is third law. So how can you do that? Like this, you can do change the second law. The second law plus 2/3 times first law. So what happens? The second row is -3, 1, -1. The 2/3 times the first row, 2/3 times, sorry, this is right? 3 over 2, sorry about that. The 3 over 2 times the first row, the 3 over 2, sorry, 3 over 2, the 3 over 2 times the first row, the 3 over times 2 is exactly 3. The 3 over times -1 is -3 over 2. 0 here and add it. And add it, we have 0, the -1 over 2 -1. So first row is 2, -1, 0, doesn't change. Second row is exactly 0, -1/2 -1. The third row, how can I do the third row? Exactly the third row plus -1 times first row. The third row is 2, -3, -4. The first row times -1 is -2, 1, 0, and add it. So we have here, what's that? 0, -2, -4. So we have 0, the -2, -4. So we have it. The next two. The you just only eliminate this one, the -1/2 is like a pivot. This is the same. First row, the second row, and the third row. You can change it to the echelon form. You can keep 2, -1, 0. You keep here 2, the -1 over 2, and -1. You can eliminate -2. How can you do that? The third row plus -4 times second row. Third row is 0, -2, -4. The -4 times the second row, the -4 times 0 is 0. -4 times -1/2 is +2. -4 times -1 is like 4. You just only add it. What's that? 0, 0, 0. The third row is 0, 0, 0. So we have it. So like this. The next, you can change it to the reduced echelon form. So you have to scale it. You multiply the second row times the -2. So top one is 2, -1, 0. The second row is 0, 1, 2, 0, 0, 0. The next here, eliminate -1. This is like a pivot is 1. You can eliminate -1. How can you do that? Same, first row, second row, third row. Exactly the first row plus second row. The first row is 2, -1, 0. You add it, 0, 1, 2. What's that? 2, 0, 2. We have here the 2, 0, 2. Bottom 0, 1, 2, 0, 0, 0. Next, you have to scale. You have to scale first row times 1 over 2 in first row. So we have reduced to echelon form. 1, 0, 1, 0, 1, 2, 0, 0, 0. So what happens? Only this portion. This is like the first column, we have pivot. Second column, we have a pivot. Yes, we have a unique solution. Was it like x1? x1 here, x1 times 1. x1 times 1 plus 0 times x2 is 1. The second one, 0 times x1 plus 1 times x2 equals 2. 1 times x2 equals 2. So we have it. What's the answer? x1 equals 1, x2 equals 2. The final answer is vector x is x1 and x2. The final answer is 1 and 2. So that's it. This is final answer. right? This is the whole idea for solving this problem. Let me see. The next example, common geometric linear transformation. We think about this one, reflection. Find the standard matrix for the transformation TR2 to R2. The reflect points about the X2, the X2. So we have this one. How can you find? So this is the idea. You can use the standard. This is like E1 and E2. Was it like E1 and E2? We think about this one. You can draw. This is like X2. This is X1. You can choose E1. E1 is 1, 0. What happens to 1, 0? You have to reflect 1, 0 about X2. The 1, 0, the move to here, only reflect. This point is going to the -1, 0. So what does it mean? The TE1 equal -1, 0. So we have it. What's T2? Here, T2 is the 0, 1. You have to reflect this one about X2 doesn't change. So we have TE2, same number, doesn't change, the 0, 1. So was it like matrix A? The matrix A is always TE1, TE2, like this. The TE1 is like -1, 0. First column, -1, 0. Second column, 0, 1. So we have it exactly same like this. This is the whole idea for finding the reflection. The reflect points about the X1 axis, we have this result. The region, the similar. So we have same. This one, this is X1, this is like X2. So we have a first one, point X1, this is like E1 is 1, 0. You have to reflect about X1 doesn't change. So we have TE1 is exactly same 1, 0, doesn't change it. What's TE2? Here, T2 is 0, 1. The reflect about X1, we have this point. This point is 0 and the -1. So we have TE2 equals like 0, -1. The same, was like matrix A. Matrix A is the first column TE1, second column TE2. So same to first column TE1, 1, 0. The TE2, 0, -1. Yes, we have it. This is the whole idea. Reflect points about the line X2, X1. We have this result. The Y, the same. So we have this one. Here, X2 equals X1 is right. X2 equals X1 is here. We have this point. This point is 1, 0. You have to reflect about X2 equals X1. Reflect here. We have 0, 1. So what does it mean? TE1 equals 0, 1. So like this. The next one, what's TE2? This is like E2, 0, 1. Reflect about X1, going back to 1, 0. So we have TE2 is going to 1, 0. So same, was it like standard matrix A? Standard matrix A is like TE1, TE2. So we have TE1 is 0, 1. The first column, second column, 1, 0. So we have it. This is the whole idea for finding the standard matrix for the linear transformation. Reflect points about the line X2 equals -X1. So we have this result, the same idea. So we have this one. The x2 is minus x1 is, this is graph. So we have it. So this is x2 equals minus x1. So we have point. This is what? 1, 0. You have to reflect 1, 0 about x2 equals minus x1. Here, the move. So we have 0, minus 1. So what does it mean? The TE1 equals 0, minus 1. Was it like a T2? Here. This is E2. 0, 1 is E2. Reflect about x2 equals minus x1. The reflect here. So we have the minus 1, 0. So we have TE2 equals the minus 1, 0. The same. What's it like a matrix A? Matrix A is TE1, TE2. Answer is next one. TE1 is this one, 0, minus 1. TE2 is second one, minus 1, 0. Yes, we have it. This is the whole idea for finding reflection result. The next one, reflect points about the origin. How can do that? So here, this is the result. So why do you have this kind of things? Same idea. So we have origin 0, 0 is given here. You have to reflect 1, 0 about origin. The reflect like this. Origin, we have minus 1, 0. So we have TE1 is minus 1, 0. Next to this point, we have 0, 1, E2. Just only reflect this point about the origin, the reflect about the origin, so we have it. This point is 0, minus 1. So we have TE2 equals 0, minus 1. You can change matrix A, same. The TE1, TE2, we can use it. So TE1 is first column, minus 1, 0. TE2 is 0, minus 1. So we have it. This is whole idea. So find the standard matrix for the transformation T from R2 to R2 that first reflects point through the horizontal x1 axis, then reflect point through the line x2 equals x1. So how can you find this idea? The same. You can calculate TE1, TE2. You can use the same idea. So here, this one, this is x1, this is x2. So x2 equals x1 is here. x2 equals x1. So you can choose the first point. This is like 1, 0. First, you have to reflect this point through the horizontal x1 axis. Here, you can reflect this point about x1 axis, doesn't change. Next, reflect point through the line x2, x1, reflect here. So we have this point. This point is like 0, 1. 0, 1. So what happens? So we have this result. TE1 is 0, 1. So we have it. Next, what's it like E2? This is like E2. The first, reflect about the horizontal x1 axis. First, reflect about horizontal axis here. You have to reflect. This one is 0, minus 1. Next, this point, reflect point through the line x2, x1. You have to reflect this point, line x2 equals x1, just to reflect like this. We have it. This point is minus 1, 0. So what does it mean? The TE2 reflect about x1 axis and then reflect about x2 equals x1. We have minus 1, 0. We have minus 1, 0. So this is the idea. So was it like a standard matrix? The standard matrix is TE1, TE2, same. So like this. TE1 is here, 0, 1. T2 is here, minus 1, 0. So that's it. This is the whole idea for solving this problem. This is the idea. Next, rotation. Find the standard matrix for the transformation T R2 to R2, then rotate each point in the plane about the origin through an angle theta. So how can you find this kind of things? So we have this idea. So here, this is the answer. First, you can the right answer. The cosine theta, sine theta, never sine theta, cosine theta. How can you find this kind of things? So we use same idea. So here, we have x1, x2. So how can you do that? This is 1, 0. You can draw, this is like 1, 0. This is 0, 1. You can draw unit circle. You can draw like a unit circle. This one. The ones is given, you can rotate this point about through the angle theta. How can you rotate here? You have to rotate this one to the like this. You have to rotate angle theta. For this point, you can use definition. This one is the same to what? X component is cosine theta. Y component is sine theta. So like this. What does it mean? TE1 equals same to cosine theta, sine theta. Cosine theta, sine theta. This is like TE1. Next here, this point is like 0, 1. Same, rotate the same angle theta. So what is point? Let me see. You can draw. So this length x is cosine theta. This length y is sine theta. This length sine. Here, same. You can make same right triangle. This one is same to cosine theta. So this length is the same to sine theta, right? The sine theta. What is point? So x component is sine theta, but the left-hand side negative. So we have negative sine theta. So cosine theta is like a positive here, exactly cosine theta. So what does it mean? TE2 is going to the negative sine theta and cosine theta. So we have it. So what's it like the matrix say? Same. The TE1, TE2. So answer is, the TE1 is this one. Cosine theta, sine theta, first column. Cosine theta, sine theta. The T2 is this one. This is TE2. The negative sine theta and cosine theta. So that's it. This is the whole idea for solving this problem. The next, contraction and expansion. Find the standard matrix for the transformation T R2 to R2 that correspond to the horizontal contraction expansion. So how can you do that? So here, contraction is K is between 0 and 1. Expansion, K is greater than 1. We have the same answer. So K, 0, 0, 1. How can you find this kind of result? So it's the same. So we have point is this one, 1, 0. So we think about horizontal contraction. The horizontal contraction, this point is move here. Exactly the K0. The horizontal contraction, the K is like this one. So what does it mean? TE1 equals K0. We have it. Next one, this point is 1, 0. So horizontal contraction doesn't move, the same. So we have TE2 equals 0, 1, doesn't move. So what's like a matrix say here? The TE1 is this one, the T2 is this one, exactly K0, 0, 1. So this answer. So what's like expansion? Only difference is the expanded horizontally, so this point is moved here. Only difference is this is K0, K is greater than 1. We have same result. TE2, this point expanded doesn't move. So we have it exactly same. Vertical contraction, expansion of plane figure. The contraction, expansion, so what's that? So here, we have this result. Why do you have this kind of things? Same idea here. This point is 1, 0. The vertical contraction, vertical expansion doesn't move. So we have TE1 equals 1, 0. Doesn't move. So vertical contraction, this is like 1, 0 here. This is 0, 1, sorry, 0, 1 here. The vertical contraction, K is between 0 and 1, contract, the move here. So we have it. This is 0K. So we have TE2 equals 0K. So what's that? The TE1 is 1, 0. The TE2 is 0K. So we have it. So what's like expansion? Same. You have to expand 1, 0 vertically, doesn't move. So here, 0, 1, expand. So we have here, expand. This is like K, 0K. So this is like 0K, just move. So we have it. So that's it. This is like vertical contraction, expansion. We have the same answer. Shears. Find the standard matrix for the transformation TR2R2 that correspond to horizontal shear K is greater than 0, K is less than 0. So what happens? You can do shear like this. We have this result, the Y, the same. What's like horizontal shear? This meaning is like this. So we have basic square. This is 1, 0. This is 0, 1. So what's like horizontal shear? K is like greater than 0. You have to push here. So what happens? So we have this kind of things. So this part doesn't change. 1, 0. You can move a little bit, like parallelogram. So this point is moved to here. This is 0, 1. The move to positive K. So we have K1. So like this. It's good. So what's that? So we have it, this result. TE1. TE1 doesn't change. So we have 1, 0. What's TE2? Here, the 0, 1 is moved to K1. So we have it. So answer is T1 is 1, 0. TE2 is K1. So we have it. So what's K is like less than 0, you have to push from here. The k is less than 0. So what's it like a graph? You can push, so we have same, doesn't change, 1, 0. So here, like this. Like this. You can move this point, the 1, 0, move to here. This is negative k, so we have k1. The k1, the t1 same, t2 same. Only difference is k is negative number. So we have same result. The vertical shear similar. K is greater than 0, k is less than 0. 1k, 0, 1. How can you know this kind of thing? So similar. So we have this one. This is 1, 0. The 0, 1 is a rectangle. This is like a square is given. You have to vertical shear. K is greater than 0. You can push from here to here. So like this. What kind of result do we have it? So we have this one. So like this. E2 doesn't change. Here, what happens to E1? The 1, 0 move to here. This point is like a K, so we have 1K. So what's that? So we have TE1. Change it to 1K. TE2. Doesn't change it, 0, 1. So we have it. So K is like less than 0. So push here. So what happens? So we have this one. This one. The 0, 1 same, doesn't change. Here, this is 1, 0. Move to here. We have, this is K. So we have 1K. K is like a negative number. So same. The only difference is K is negative, K is only positive. That's it. This is the whole idea. So we have this result. The projection. Find the standard matrix for the transformation T, R2 to R2 that corresponds to projection onto the X1 axis. I can do that. The 1, 0, 0, the Y. So reason is like this. So need projection onto the X1 axis. How can do that? Here. So we have this one. This point 1, 0. This is 0, 1. So what's that? So here we have the one schedule X1. You have to project to X1 axis. 1, 0 is going to 0, 0. So 0, 1 doesn't change. So we have TE1 doesn't change. Exactly E1, 1, 0. Was like a TE2? TE2 going to origin 0, 0. Just to the project onto X1 axis. So we have 1, 0 is here. The 0, 0 is 0, 0 is here. So we have it. So that's it. This is the whole idea. TE1 doesn't change. TE2 is going to 0, 0. The projection onto X2 axis, so like this. Similar idea. How can do that? Here. So we have 1, 0. This is 0, 1. So we have schedule like this one. The project onto X2 axis. The project onto X2 axis here. So 1, 0 move to 0, 0. So we have TE1 equal 0, 0. Was like a TE2 doesn't change. Doesn't change 0, 1. Was TE1 0, 0 is first column. The 0, 1 is second column. So we have it. So this is the answer of this question. The next tip, onto transformation. The A mapping T, Rn to Rm is onto Rm. What does it mean? If each B in Rm is the image of n leads to 1x in Rn. What does it mean? The Rm is exactly same to range of T, the range of T. The another word for each B in Rm, Tx equals Ax equals B has a unique solution or more than one solution. The solution always exists. Solution always exists. So you can change it like matrix form. So what does it mean? Each row has a pivot. So each row has a pivot. This is key. What's that? Each row has pivot. So what's it like a geometric description? So geometric description is like this. So we have here, this is Rn domain. This one is Rm. You can think about linear transformation. So this part is going to this point, the x is going to like B. So you can find all images like range. In this case, Rm is exactly same to range of T. So this T is onto. So this is example. This is like here. So we have this one is like Rm. This is Rn. This is Rm. We think about this one, T. So what happens range? The range is not whole Rm, some part of Rm, only this part. It's like only range of T. The range of T is not exactly same to Rm. So what does it mean? T is not onto. This is like geometric meaning. The geometric meaning. So this is example. Let T be a linear transformation whose standard matrix does T maps R4 onto R3 or not. How can you know that? You can change it to the echelon form. You can change it to what? Echelon form. So here, change it. This is the first row, second row, third row. So what's it like this one? You can keep first row, 1, -4, 8, 1. This is second row plus -2 times first row. The second row is 2, -6, 15, 5. The first row times -2, 1 times -2 is -2. -2 times -4 is +8. -2 times z is -16. -2 times 1 is like -2. In this case, this is not argument matrix, only matrix. Only matrix. Here, you add it. We have 0, 2, -1, 3. We have 0, 2, -1, 3. Third one. Third one plus -3 times first row. We have 3, -2, 24, 8. This is like third row plus the -3 times the first row. The -3 times the first row is 1 times -3 is -3. -4 times -3 is +12. 8 times -3 is -24. And the -3 times 1 is -3. So you add these two rows. We have 0, 0, 0. What's that? +5. So we have 0, 0, 0, 5. This is onto one. You can check. The first row has pivot. Second row has pivot. The third row has pivot. Each row has a pivot. Pivot. So what does it mean? The T is onto. Yes, T is onto. Each row has a pivot. What does it mean? You can change it to the augmented matrix, like this one and the P or something like that. So we have a unique solution or infinity many solution, right? So like this. So next one, one-to-one. Mapping T Rn to Rm is one-to-one. So what's that? So each B in Rm is the image of m most 1x in Rm, right? So we have this kind of things. For each B, Tx equals X equals B has unique solution or no solution. It doesn't matter. Unique solution or no solution. We call the one-to-one. So what does it mean? Each column has a pivot. This is like the main part. Each column has a pivot. Each column has a pivot. The geometric description is like this. So here we have Rn domain. So here we have Rn. This is Rn. So you can define range. This is like a range is here. This part is range. You can choose x1, x2, x3. So x1 is going to some point, x2 is going to another one, this one is going to the other one. What does it mean? The function value is totally different. This is one-to-one. This is one-to-one. But here we have it. This one is similar. This is R, sorry, this is Rm. This is Rn. This is Rm. We think about linear transformation T, the mapping T. So here you can draw range. It's like range is some part. Sometimes the whole thing, it doesn't matter. The Rm is exactly same to like the range of T or different, it doesn't matter. It doesn't matter in for checking one-to-one. So here, this one, what does it mean? We have choose two different point is going to what? Same number, like same number, not one-to-one. This is like x1, this is like x2. What does it mean? Tx1 is the same to tx2. Same function value, but x1 is different x2. This is what does it mean? Not one-to-one. The same point, not one-to-one. Just like a geometric meaning, not one-to-one. So like this. So I'm gonna give one more example. T is this one. So what's that? So this is exactly same to previous one. The same to previous one. You can use same procedure. You can find, what's that? You can find the echelon form. You can find echelon form. You can find like echelon form. What do you like echelon form? Echelon form is this one, right? This is echelon form. So we have it. So you can use same method. We have echelon form from the previous example. 1, -4, 8, 1. This is 0, 2, -1, 3. Here, 0, 0, 0, 5. So this is, we don't have B, exactly, only the coefficient matrix. So 1, the first column has pivot. Second column has pivot. The third column, no pivot. The first column, yes, we have a pivot. So we don't have a pivot in the third column. What does it mean? Here, each column doesn't have a pivot. So what is like a final answer? The T is not one-to-one. Not one-to-one. Not one-to-one. Is right? Not one-to-one. What does it mean? You can change AX equals B. For some B, the T has infinity many solutions, not unique solution. So this is like idea. Okay. So this is exactly section 1.9. So if you have any question, any trouble, send the email to me or like let me know in class. I can help you. So thank you for watching my lecture video in section 1.9. Yeah, that's it.